Good morning, students. Welcome to the 39th lecture of refrigeration and air conditioning subject. Today we are in the unit 5. In the last class we have discussed about the introduction of psychrometric properties and their formulas. Today in this class we'll discuss about the problems related to the psychrometric problems. Okay. So in the last class we have continuing the problems related to the psychrometric properties. Today in this class we are continuing the balance problems. The humidity ratio of atmospheric air at 28 degrees centigrade, dry bulb temperature and 760 mm of mercury is 0.016 kg per kg of dry air. Determine the partial pressure of water. Determine the partial pressure of water vapor, the relative humidity, the dew point temperature, the specific enthalpy, the vapor density. Right. So from the given problem, first write the given data. So what is the given data? That is what is the temperature. The temperature, the atmospheric pressure of air, dry air is equal to 28 degrees centigrade, and the mercury is equal to FB, PB is equals to 760 mm of mercury, and determine what is the what is the weight. Weight is equals to 0.016 kg per kg of dry air. So what is the data to find? Right, determine the partial pressure of water vapor, the relative humidity, the dew point temperature, the specific enthalpy, and the vapor density. Now find, let PV is equals to partial pressure of water vapor to find. We know that humidity and కాబట్టి the humidity ratio as per the psychrometric property, humidity ratio W is equals to, this is a formula, 0.622 divided by into PV divided by PV minus PV. So substitute 0.622 PV divided by 760 minus PV. So taking cross, so we are getting, after substitution, after getting the calculations, we are getting PV is equals to 19.06 mm of mercury. That implies PV is equals to 2540.6. Next, what is the thing to find? The relative humidity. From the steam tables, the saturation pressure of water vapor corresponding to a dry bulb is 28 degrees centigrade. Therefore, steam tables PS is equals to 0.03778. That is equal to 3788 Newton per meter square. Therefore, the relative humidity pi is equals to PV by PS. That implies 2540.6 divided by 3778. That is equal to 67.2%. That is a relative humidity. Next, the dew point temperature. The dew point temperature is the saturation temperature corresponding to the partial pressure of the water vapor. Therefore, from steam tables, the corresponding pressure is equals to 2540.6. The dew point temperature is equals to, temperature dp is equals to 21.1 degrees centigrade. Therefore, the specific enthalpy from the steam tables, the temperature is equals to 21.1 degrees centigrade, that is equals to HFGDP, that is equals to 2451.76 kilojoules per kg. The specific enthalpy H is equals to 1.022 TD plus W. So this is a specific enthalpy formula. H is equals to 1.022 TD plus W, HF GDP plus 2.3 dP. That implies, so after substituting the values of TD, W, HF GDP, so finally we are getting the H value is equals to 68.62 kilojoules per kg. Now what is the vapor density? The vapor density, as per the rule, we know that the vapor density rho V is equals to, the formula is rho V is equals to W of PB minus PV RA TD. That implies, after substituting the values, we are getting the total value rho V is equals to 0.0183. Got it? Right. Now, in the next problem. A room of 7 meters into 4 meters into 4 meters means the length, breadth and width. Volume, a room of the volume is occupied by air water vapor mixture at 38 degrees centigrade. The atmospheric pressure is 1 bar and the relative humidity is 70 degrees centigrade. Determine the humidity ratio, the dew point, mass of the dry air, mass of the water vapor. If the mixture of air water vapor is further cooled at constant temperature until the temperature is 10 degrees centigrade, find out the amount of water vapor condensed. Find out the amount of water vapor condensed. Now write the given data. So what is the room size? Given V is equals to 7 into 4 into 4. Now what is the TD? Temperature is 38 degrees centigrade, that is equal to 38 plus 2 to 73. And the pressure is equal to 1 bar. The humidity ratio is 70 degrees. Now find out the humidity ratio. So before that, from the steam tables, we have to get the value of saturation pressure, right? So in order to get the, so why we are discussing before the saturation pressure? So because the humidity ratio formula, so based upon the humidity ratio formula, we know the value of PS. So we have to get the value of PV. Okay, we have to get the value of PV. So the relative humidity is equals to, this is a formula, 0.7 is equals to PV by PS. Therefore, PV is equals to 0.7 PS. That is equal to 0.7 into so on so. Therefore, the humidity ratio W is equals to 0.622 into PV divided by PV minus PV. So after substituting the values, so getting the values finally, we get W is equals to 30.2. Now, the dew point temperature. Since the dew point temperature TDP, since the dew point temperature is the saturation temperature and the partial water pressure PV from the steam tables, the pressure of 0.046368 bar, the dew point temperature is TDP is equals to 31.56 degrees centigrade. Therefore, the mass of the dry air, let MA is equals to mass of the dry air, PD is equals to pressure of the dry air, PB minus PV. That implies 1 minus 0.046368. That is equals to 0.953632. Therefore, 0.953633 into 0.10 to the power of 5 is equals to 95363.2. Therefore, 1 bar is equal to 10 to the power of 9 Newton per meter square. Therefore, we know that PV is equals to MRTD. PV is equals to MRT. Therefore, PAV is equals to MA RA into TD. Therefore, MA is equals to PA by RA into TD. So getting the values. So MA is equals to 120 approximately kgs. That is the mass of the air. Next, the mass of the water vapor. Let MV is equals to mass of the water vapor. Therefore, the humidity ratio W is equals to, so this is the formula. 0.0302 is equals to My by Ma. Therefore, MV by MV value. So MV is equals to so and so. So finally, the value is equal to 3.61 kilo kgs. Next, the amount of water vapor condensed. So if the temperature is 10 degrees centigrade, from the steam tables, so for getting the saturation pressure, so in order to get the value of water vapor condensed, we have to know the value of saturation pressure. The saturation pressure PS is equals to PV, that is equals to 0.01227 bar. Therefore, the humidity ratio W is equals to 0.622 PV divided by PB minus PV. So after getting the substituting the values, the W is equals to 0.007632 divided by 398773. W is equals to this value. Now, the pressure of the dry air, PA is equals to PB minus PV. Pressure of the dry air, PA is equals to PB minus PV. So PB value 1, PV value 0.0127. So that implies 0.98773. So PA value is equals to 98773 Newton per meter square. Therefore, the mass of the dry air MA is equals to PV by RT. So PA value into V value divided by 287 into 10 plus 273. So 136.2 kg. Now the mass of the water vapor M is equals to W into MA. M is equals to W into MA. That implies after substituting the value of W and MA, WMV is equals to 1.053 kilos. Therefore, the amount of water vapor condensed is equals to 3.61 minus 1.053, that is 2.557 kilos. Next one. From the sample of air having 22 degrees DDP, the relative humidity 30% at barometric pressure is 760 mm of mercury. Calculate vapor pressure, humidity ratio, vapor density and enthalpy. Now, given data TD is equals to 22 degrees, pi value is equals to 30%, that is 0.03. Mercury PB is equals to 760 mm of Hg, that is equal to 760 into 133.3, that is equals to 101308 Newton per meter square. So converting into bar. Now, what is the thing to find the vapor pressure? The vapor pressure is equals to, we know the value. Okay. Now, let PV is equals to vapor pressure. From the steam tables, the saturation pressure of vapor, pressure of vapor corresponding to the dry bulb temperature of 22 degrees is equal to PS is equals to 0.02642 bar, right? Now, the relative humidity 0.3, is equals to PV by PS is equals to 0.3. PV by 0.02642. PV is equals to 0.007926 bar. Next one, humidity ratio. So we have to by heart these formulas. Humidity ratio W is equals to 0.0622 PV, 0.0622 PV divided by PB minus PV. That implies vapor density, we know that the vapor density PV rho V is equals to W of PB minus PV into divided by RT RATD value. That implies W is equals to 0.0049 substitute value of PB minus PV 10 to the power of 5 divided by substitute value of RA 287 plus TD is equals to 273 plus 22. Therefore, the value rho V is equals to 0.00582 kg per meter cube of dry air. Now, what is the thing to find? The enthalpy. The enthalpy from the steam tables, we have to find the saturation temperature. For that, we have to get the value of PV from the steam tables. PV is equals to 0.007926 bar. TDP is equals to 3.8 degrees centigrade. And the latent heat of the vaporization of water at dew point temperature of 3.8 degrees centigrade HFG TP is equals to 24.926 kilojoules. Now, the enthalpy H value is equals to, what is the H value here? The H value is equals to 1.022 TD plus W of HFGDP plus 2.3 TB. H is equals to substitute the value, right? Now H is equals to so and so 34.74 kilojoules per kg. Now the next thing to be discussed is psychrometric processes. Initially we have discussed about psychrometric properties, that is dry bulb temperature, wet bulb temperature, so on so. Now we'll discuss about psychrometric properties. That first one is sensible heating process. Sensible heating process. Second one is sensible cooling process. Sensible cooling process. Humidification process. Dehumidification process. Heating and humidification process. Cooling and dehumidification process. Cooling and humidification process. Heating and dehumidification process. Now, coming to the first point, sensible heating. So in the sensible heating, the heating of air without any change in the specific humidity. So during the process, we are heating the air. So whenever we are heating the air, so we should not change the specific humidity value. We should not change the specific humidity. So the specific humidity properties gurinchi we have discussed in the last class also. So the heating of air without changing the humidity is known as sensible heating. Let air at temperature TD1 passes over the heating coil of temperature TD3 as shown. It may be noted that the temperature of the air leaving the heating coil TD2 will be less than the TD3. The process of sensible heating on psychrometric chart is shown in the horizontal line 1 2 extending the left to right as shown in the figure. The point 3 represents the surface temperature of the heating coil. So generally మీకు ఇదంతా ఉండదు as per exam point of view, only what is the definition of sensible heating and we will make it some of the problems according to the formula. The heat observed by the air during the sensible heating may be obtained from psychrometric chart by the enthalpy difference H2 minus H1. It may be noted that the specific humidity during the sensible heating remains constant, that is W1 is equals to W2. The dry bulb temperature increases from TD1 to TD2 and the relative humidity reduces from pi1 to pi2. The amount of heat added during the sensible heating may also be obtained from the relation heat added is equals to H2 minus H1. That implies CPA of T2 minus TD1 plus WCPT TT2 minus TD1. So Q is equals to adding it CPA TD2 CPA plus WCPS TT2 minus TT1, that is equals to CPM into TT2 minus TT1. Next. So these are the substitution values. So don't worry, it will not come in the exam. The term CPA plus WCPD CPS is known as humid specific heat. Humid specific heat, that is CPM. And the value is 1.022 kilojoules per kg. Therefore, heat added is equals to Q is equals to 1.022 TD2 minus TD1 kilojoules per kg. Now, the sensible heating diagram as per the theory in the last slide. See here. So, we are having the process where in the process we are having a heating coil T D3. The air is going inside this chamber and the hot air is going outside. Means air in is equals to is referred as TD1, air out is referred as TD2, and heating coil is referred as TD3. So here the steam is passing from this chamber, this layer to the other set. So from this we are taking the graph. So from this graph for this dry bulb temperature and the specific humidity, pi values pi1, pi2 and pi3 are shown in this figure. So W is equals to W1, W2, H1, H2 and H3. So from this psychrometric chart, so for sensible heating, heat or hot water, steam or hot water is passed through the heating coil. The heating coil may be the electric resistance. This heating coil may be the electric resistance coil, and the sensible heating of the moist can be done by any desired temperatures. Next one. So ఇందాక మనకి sensible heating అయింది. Now it is sensible cooling. So in the sensible cooling, the cooling air without changes in the specific humidity. So initially what we have took for this the cooling of air. Second one, heating of air in the specific humidity. So the heating of air without any change in its specific humidity, that is sensible heating. And ikkada the cooling of air without changes in its specific humidity is known as sensible cooling. Therefore, the air at temperature TD1 passes over the cooling coil of temperature TD3. Now, the temperature of air leaving the cooling coil TD2 will be more than TD3. The process of sensible cooling on the psychrometric chart is shown by the horizontal line 1 to 2 extending from right to left. The point 3 represents the surface temperature of the cooling coil. Now, the psychrometric process, air in, air out, the same thing, the cooling coil air passes in this way. So from this figure, by drawing the graph, the dry bulb temperature and the specific humidity, that implies TDS, TT2, TD1, that is equals to W1 is equals to W2 TDP. That is 1, 2 and 3. For that we are getting the enthalpy H1 and H2 and H3. So based on it, the formulas related to the thing is from the air conditioning, because it is cooling process, from the air conditioning purposes, the sensible heat per unit is given as SH is equals to MA into CPM into delta T. MA into CPM into delta T. that is equals to V rho into CPM into delta T, where since M is equals to rho into T, V value is equals to rate of dry air flowing in meter cube per minute. Rho is equals to density of moist air at 20 degrees centigrade, that is equal to 1.2 kg per meter cube. CPM is equal to specific heat, that is equal to 1.022, and delta T is equals to TD1 minus TD2, difference of dry bulb temperature between the entering and leaving the conditions of the air in degrees centigrade. Substituting the values, SH is equals to V into 1.2 into 1.022 into delta T. So this is the value. So SH is equals to this one. So for sensible cooling, the cooling coil may have the refrigerant, cooling water or cooling gas flowing through it, right? So for the sensible heating, definitely we require a refrigerant which should be attached to that. For the sensible cooling, so the refrigerant should be placed so that the cooling water or the cooling gas should flow inside the coil. So that is about the sensible heating and cooling. Next. So the next topic is humidification and dehumidification. One second. Humidification and dehumidification. Yes. Next one is, sorry, one second. Next one is humidification and dehumidification process. So this is the third process in the psychrometry process. So the figure shows the ultrasonic humidification system. Ultrasonic humidification system. The addition of moisture to air without change in its dry bulb temperature is known as humidification. So what it is saying, humidification means the addition of moisture to the air. So generally we are adding moisture content to the air without change in its dry bulb temperature. So we are not changing the temperature at the dry bulb place and adding the moisture to the air without change in its dry bulb temperature is known as humidification. So similarly, removal of moisture from the air without change in its dry bulb temperature is known as dehumidification. Then what is the dehumidification? Removal of moisture from the air without change in its dry bulb temperature. So adding up of moisture to the air and removal of moisture from the air, right? So without changes in the dry temperature is known as humidification process and dehumidification process. So very simple definition. What is the definition here? Humidification means addition of moisture to the air without changing its tribal temperature. So simply addition of moisture to the air without changing its dry temperature is known as humidification, and removal of moisture from the air without changing its tribal temperature is known as dehumidification process. The heat added during humidification process and heat removing during dehumidification process is shown in the psychrometric chart as shown in the figure. So this is ultrasonic humidification system where in order to test the moisture content in the air. So from the given data, it may be noted that in the humidification, the relative humidity increases from pi1 to pi2 and specific humidity increases from W1 to W2. Therefore, in the dehumidification process, the relative humidity decreases from pi1 to pi2 and specific humidity also decreases from W1 to W2. Now, what is the humidification? In this humidification, see here, for the dry bulb temperature and the specific humidity, weight is equals to W1 of the air. W2 is passing from W1 to W2. Therefore, the pi value is equals to, at this point is pi1 and then this point is pi2. Now, the humidity, the enthalpy is equals to H1 and H2. Now, at the same time for dehumidification process, for a dry bulb temperature and specific humidity at W1 and W2, so we are having the value 1, 2 is going down, means we are removing the moisture from the air, so it is going down. So pi1, pi2 value. So H1, H2, that is the enthalpy. H1, H2 is the enthalpy. So we are getting the value in this process for the dehumidification process. So humidification process లో మనకి పైకి జరుగుతుంది process. See the arrow here. So it is going from W1 to W2, but here it is going from down W1 to W2. This is about dehumidification process. So whenever you are seeing an experiment, it may be noted that in the humidification process, change in the enthalpy is shown by the intercept on the psychrometric chart. Intercept means H2 minus H1 difference. Since the dry bulb temperature of air during the humidification, since the dry bulb of the air during the humidification remains constant, the sensible heat also remains constant. Therefore, it is obvious to change in the enthalpy per kg of dry air due to the increased moisture content equal to W2 minus W1 kg per kg of air is considered to cause a latent heat transfer LH. So mathematically LH is equals to H2 of H2 minus H1, that is equal to HFG W2 minus W1. Therefore, HFG is a latent heat of vaporization of a dry bulb temperature TD1. Now, third one is a sensible heat factor. A matter of fact, the heat added during the psychrometric process may be split up into sensible heat and latent heat. That's the first thing. The ratio of the sensible heat to the total heat is known as sensible heat factor. So simply, what is the definition? The ratio of sensible heat to the total heat. Sensible heat to the total heat is known as sensible heat factor. Next. The ratio of sensible heat to the total heat is known as sensible heat factor. Written as sensible sensible heat factor SHF, or sensible heat ratio, HHR. Therefore, mathematically, HF is equals to sensible heat divided by total heat. That is equals to SH divided by SH plus LH. The sensible heat SH is equals to this one, and LH is equals to latent heat. The sensible heat factor scale is shown on the right hand side of the psychrometric table. So that is sensible heat factor. Next one is heating and humidification process. So ఇందాక మనం చెప్పుకున్నది humidification, dehumidification, sensible heat factor, and heating and humidification, which are the processes in the psychrometric chart. Okay, next. The process is generally used in the winter air conditioning. So heating and humidification ekkada use chestamu? This process is generally used in the winter air conditioning to warm and humidify the air. So for example, this type of system is generally seen in the other countries like Canada, New Zealand, Germany, Europe countries. Why? Because in the winter season the temperature is -degree centigrade, so it may go to -10 degrees, -18 degrees. So at that point of time, those people living there require this type of heating and humidification process, where in the winter process the air will get warm and humidify the air. It is the reverse process of cooling and dehumidification. It is a reverse process of cooling and dehumidification. When air is passed through a humidifier, having spray water temperature higher than the dry bulb temperature of the entering air, the unsaturated air will reach the condition of saturation. Therefore, the air becomes hot. So you can put air hot అవుతుంది when the air is passed through the humidifier. So this is a, see the setting, the humidifier. When the air is passed through the humidifier, having spray water temperature higher than the dry bulb temperature of the entering air, the unsaturated air will reach the condition of the saturation and thus air becomes hot. The heat of the vaporization of water is observed from the spray water itself and hence it gets cooled. So in this way, the air becomes heated and humidified. The process of heating and humidification is shown on the psychrometric chart. The air enters at condition 1. The air enters at condition 1 and leaves at condition 2. In this process, the dry bulb temperature as well as the specific humidity of the air will increase. The final relative humidity of the air can be lower or higher than that of the entering the air. That is the humidification and dehumidification. So from seeing the graph for the heating and humidification, the dry bulb temperature and the specific humidity process. So the for W1 and W2. So we are getting the points of H1, we are getting the points of H2, we are getting the points of T1, T2 and T3. Okay, that is Tg1 and Td2. Now the dry bulb temperature, the specific humidity. So here we are considering Td1 and Td2. Therefore at the W1 and W2. So here at the point A, and we are considering a triangle point 1, 2, A, where H1, H2 and HA, that is SH1 and LH, that is a enthalpy value. Okay, now from the graph, let MW1 and MW2, mass of the spray water entering and leaving the humidification in kgs, and HFW1 and HFW2 is equal to enthalpy of the spray water entering and leaving the humidifier. and W1 and W2 is equal to specific humidity of the entering and leaving of air in kg per kg of dry air. Now H1 and H2 is equals to enthalpy of entering and leaving air in kilojoules per kg of dry water. Right? H1, H2 enthalpy of entering and leaving of air in kilojoules per kg of dry air, and Ma is equals to mass of the dry air entering in the kilograms. So for mass balance of the spray water, MW1 minus MW2 is equals to Ma of W2 minus W1. Therefore, MW2 is equals to MW1 minus Ma of W2 minus W1. From the enthalpy balance, and for enthalpy balance, MW1 into HFW1 minus MW2 into HFW2, that is equals to Ma of H2 minus H1. Now substituting the values of value MW2 from the equation 1, we get MW1 HFW1 minus of MW1 minus Ma of W2 minus W1 HFW2. That implies Ma of H2 minus H1. Therefore, H2 minus H1 is equals to MW1 divided by Ma, that is equals to HFW minus HFW2 plus W2 minus W1 HFW2. That is about heating and humidification process. So we'll stop the class here. So we'll discuss the class in the next session. So in this class, we have discussed about the problems related to the psychrometric properties and also the psychrometric processes, that is humidification, dehumidification, heating and humidification, heating and dehumidification, like that. So from tomorrow, we'll discuss the later psychrometric process and we'll close the psychrometric process, right? So we'll stop the class. Have a nice day. Thank you. So we'll discuss in the tomorrow's class.